Okay, here's the promised video. All I'm going to do is just do one example, and I'm going to do the increasing, decreasing part and the concavity part, just to make sure that you're okay. So you might want to watch this video and then go do your homework. You can pause the video and take notes. Then you'll have one where you do increasing, decreasing, and we'll talk about maxes and mins and concavity inflection points all on the same example in your notes. And that might be helpful. Okay, so I'm going to go share a PowerPoint, I hope. All right, let's see if it'll pull up, and it's really just one slide. Okay, it's just one example. I'm going to kind of talk us through it. All right, so the work's already done, but just kind of pay attention and watch me kind of talk you through it. So you have to kind of pause and take notes and then reverse and that kind of thing. Okay, here's the equation. All right, here's your original equation. All right, let's try this. All right. You've got y is a negative 2x to the fourth plus 3x squared. So this was your original equation. And I want to know where it increases and decreases. Now, increasing, decreasing, maximums, and minimums all go with the first derivative. So I'm going to take the first derivative. So power rule, that 4 comes down. So I've got a negative 2 times 4 is a negative 8. My variable stays the same. My power goes down by 1. So that's why I got a negative 8x cubed plus, and the same thing. That 2 comes down, so the derivative of 3x squared is 6x. Now, once you get the derivative, remember the next step is to factor completely. So I noticed that both had an x and a 2, so I pulled it out. Now, I could have pulled out a positive 2x or a negative 2x. It doesn't matter. I just arbitrarily pulled out the negative. I just personally like my lead one, my lead coefficient, positive, but you'd get the same answer either way. So what do you multiply negative 2 by to get negative 8? 4. What do you multiply x by to get x cubed? X squared. Now, do you see why this had to be a minus? Because I need this to be a plus. So a negative times a negative is going to give me that positive. So this thing is factored completely. Now, I could factor this with the quadratic formula if I wanted to. I just chose not to, and I'll show you why. So do you see that one of my factors is a negative 2x? So I put a negative 2x on here. Now, when is a negative 2x equal to 0? It's equal to 0 when x is 0. Now, what you could have done is you could have put negative 2 as a factor and then x as another factor. So then your table would have had 3 factors instead of just 2. That would work. So I picked a number smaller than 0, like negative 1. Well, see, negative 2 times a negative 1 is going to give me a positive. So that's why I put a positive. Pick a big number like 3. Negative 2 times 3 is going to be a negative 6. So I got negatives on this side. Now, what's the split point for 4x squared minus 3? When is that equal 0? Well, see, because this thing's not what we call fully factored, I'm going to get more than one split point. So if I'd used the quadratic formula, I would have gotten x minus one of these and x plus the other one. Okay, so your choice. So 4x squared is going to be 3. I divided both sides by 4, and I got x squared is going to be 3/4. Okay. And then I took the square root of 3/4. Well, now the square root of a fraction is the square root of the numerator over the square root of the denominator, and the square root of 4 is 2. So I've got a positive square root of 3/2, and I've got a negative square root of 3/2. So because this one wasn't fully factored, that's why I got 2 split points. A negative square root of 3/2 and a positive square root of 3/2. So that's kind of what happens when you don't fully factor something. All right, so if I have 2 split points, I've got to test on lots of sides. So I've got to test to the left and to the right of this one, and to the left and the right of that one. Now, I went to my calculator and did a negative square root of 3 divided by 2, and I got a decimal approximation. Now, that's just because I'm going to need to be able to plug a number in there, and I didn't know what number was smaller than this number. But I know like a negative 10 is smaller than a negative 2 point something. If I square a negative 10, I get 100. And 400 minus 3 is indeed positive. Now, the easiest number I know to the right of this negative number right here is 0. So 0 squared is 0. 4 times 0 is 0. 0 minus 3 is negative 3, so it's negative. All right. So again, if I think of a number to the left of this one, I can still use 0. See, it's negative, but I need a number to the right of this 2.1. So again, maybe I pick 10. 10 squared is 100. 4 times 100 is 400. 400 minus 3 is indeed a big old positive number. So I've got both of my factors with their split points on there, and I'm multiplying them. So a positive times a positive is a positive. All right. A positive times a negative is a negative. A negative times a negative is a positive, and a negative times a positive is a negative. So these are my final answers. So remember, where the final answer is positive on the first derivative, it's increasing. Where the final answer is negative on the first derivative, it's decreasing. So it's positive here. It's also positive here. So I said it's increasing from negative infinity to the negative square root of 3 over 2. Union is or, so or, union. It's also positive from 0 to the square root of 3 over 2. Where is it decreasing? Well, that's where the final sign on the first derivative is negative. So that would be negative square root of 3 over 2 to 0. And then from what? The square root of 2 up. So the square root of 3 over 2 to infinity. Now, how do you do relative maximums and relative minimums? Well, remember, it's going up and then it's going to turn and go down. So what do you have at that turn? If it's going up and it turns and goes down, wouldn't you have a max? So I've got a relative max at negative square root of 3 over 2 something, and that was blank. Then I know I'm coming down, and then I'm going to turn and go back up. So if you're coming down and you turn and go up, what do you have to have right here at the turn? Do you see you have to have a minimum? So I've got a relative minimum at 0, comma something, and that was just blank. Then you're going back up, and now you're turning and going back down. So again, what are you going to have at that turn? Aren't you going to have another max? So you've got a relative max at the positive square root of 3 over 2. Now, where in the world did I get those y numbers? Didn't I plug all of these basically into my original? Well, 0 is easy. If you plug 0 here for x, you're going to get 0 back out. So 0, 0. Now, plugging in these were a little more fun. So look what I did. I plugged in the square root of 3 over 2 for x here and here. Well, what happens when you take the square root of 3 to the 4th power? When I think about it, the square root of 3 times the square root of 3 gives me a 3. And another square root of 3 times the square root of 3 gives me 3. And 3 times 3 gives me 9. So if I didn't have my calculator, I could just still do it. So that's 9. 2 to the 4th power is 16. Well, a negative 2 times 9/16 is a negative 18/16. Well, look what happens when you square this. When you square the square root of 3, you get 3. And when you square 2, you get 4. So 3 times 3/4 is 9/4. Then you need a common denominator. All right, I reduced that one to make my numbers a little smaller. So that reduced to a negative 9/8. And I've got plus 9/4. So I got a common denominator of 8, and my answer came out to be 9/8. So 9/8 went right there. Now, luckily, these are even, these powers I've got, you can't see it very well. The original was a 4 and a 2. So when I make them negative, aren't I going to have exactly the same answer? Because I'm still going to get a positive 3/4 and I'm still going to get a positive 9/16. So I got the same y values there. All right. Okay. Now, what if I want to do concavity? Concavity deals with the second derivative. So now this is what I would do. I don't like quotient rule and product rule very much because there are more steps and I'm very careless. So if I'm going to do the second derivative, I'm not going to use my factored form. I'm going to kind of come back up here to my unfactored form. I'm going to kind of start right there and take the derivative instead of starting, because I don't want to do product rule. Okay. All right. So I'm going to come up here and take the derivative of this. So that's going to be a negative 24x squared plus, and then the derivative of 6x is just 6. And see, that's way better than doing this one times the derivative of that plus that times the derivative of that. So when you're doing concavity, go back to the unfactored form to take your second derivative. All right. Then remember, now I'm going to fully factor the second derivative. So I notice I can pull out either a 6 or a negative 6. And like I said, I kind of like my lead number, my lead term being positive. So that left me 4x squared minus 1, which is the difference of perfect squares. So that factors into 2x minus 1 and 2x plus 1. So this one's fully factored. So I shouldn't get more than one split point for any factor. So a -6 is one of my factors. So it goes on there. It doesn't have a split point. -6 is just negative all the time. It's never equal to 0. All right, then I put 2x plus 1 on there. It doesn't matter what order. Now, how did I get the split point? I set 2x plus 1 equal to 0. So remember, when you set 2x, when you set your factor equal to 0, that's how you get the split point. Kind of sad, isn't it? It's hard to do with this little, without a mouse. So do you understand that's going to give me 2x is a -1, so x is a -1/2. So that's why this -1/2 right here is going with this factor right here. So again, I plugged in a smaller and a bigger. So like I could plug in like a -1. 2 times a -1 is a -2 plus 1 is a negative number. An easy number to the right of a -1/2 is 0, and 2 times 0 is 0, 0 plus 1 is 1, so that's why that's positive. Okay? Then I went and got my last factor. So my last factor was 2x minus 1, and there's no reason that I'd reverse these over here. It doesn't matter what order they are on the table. I was just kind of making a point. All right? So the split point for 2x minus 1, that thing's equal 0 when x is a half. So now I'm at this half, and I'm only looking at that and that. So again, I picked a number to the left. Well, 0 is smaller than a half. So 2 times 0 is 0. 0 minus 1 is a -1, so it's negative. Then it turns positive because you could plug in like 5. 10 minus 1 is 9. All right, so I've got everything on my table. So I do what it says, which says multiply. Well, a negative times a negative is a positive, and a positive times a negative is a negative. All right, what about here? A negative times a positive is a negative, and a negative times a negative is a positive. Over here, a negative times some positive stays negative. So where your final answer is positive, it concaves up. So my final answer is positive between -1/2 and 1/2. So that's where it concaves up. Where its final answer is negative on the second derivative, it concaves down. So it concaves down until I get to -1/2. So negative infinity to -1/2, or union is or, 1/2 up, 1/2 to infinity. Now, inflection points are where the concavity changes if there's a point there. So it changes for concave down to up right here. So -1/2 comma something might be an inflection point. And then it changes from concave up here to concave down. The change occurs right there. So at 1/2 comma something. Now again, where did I get these y values? I plugged back into my original. So remember, my original is a -2 x to the 4th plus 3x squared. So I plugged in, well, 1/4 to the 4th, 1/2 to the 4th power is 1/16. So a -2 times 1/16 is a -2/16, which is a -1/8. And then 1/4 squared, 1/2 squared is 1/4, and 3 times a 4th is 3/4. I got a common denominator of 8 and ended up with 5/8 for my answer. And then luckily, like I said, if I change that to a -1/2 here and a -1/2 here, I'm going to get the same thing. So that's what you have to do for your homework. Sometimes you're finding increasing and decreasing. Sometimes you're finding concavity. On your third test, you're going to find all of that to the same problem. So I wanted one of those in your notes. Okay. So you might want to freeze it if you haven't and copy all that in your notes. Then you've got one you've kind of done everything to. So for increasing and decreasing, you just take the first derivative, factor it completely, and make a split point table. Where the first derivative is positive, it's increasing. Where the first derivative is negative, it's decreasing. Then you get your maxes and mins off that table. To do concavity, you take the second derivative and factor it completely and do a split point table. Where the second derivative is positive, it's concaving up. Where the second derivative is negative, it's concaving down. And where the concavity switches, you have inflection points. Now, like we did in class, if you substitute back in and there's no point, just erase it and say, I don't have one. Okay. So I hope that helps you with your homework. Okay. So try it. Let me know if you have any problems, and I'll see you next week. I hope you have a great weekend.